Hello, it's Kabo, and in this video I'm going to talk about structures, specifically about something really fun you can do with structures now that they actually have save data on the hard drive. So the background behind this is in 1.6.3, Mojang added a new feature to Minecraft that will save structure data. The reason for this is because if you went from one version to another where the structure generation code changed for any reason, they tweaked a random variable here, or they added chest generations to nether fortresses, for example, it would change the configuration of the virtual structure object in the world, and as a result things would break. Like nether fortresses wouldn't spawn blazes and wither skeletons in the places where you would expect them, or witches wouldn't spawn in witch huts. Even though the physical objects were there, the virtual object wasn't quite right, so it didn't work out. Sometimes the virtual object didn't even exist. So they implemented a fix to solve this problem, and as a result also added save data for the structures to the Minecraft save files. And that save data, you can actually go in with the right tools and the right know-how, play around with it, change things, and do some really cool stuff. And that's what I'm going to talk about. So let's go ahead and get into it. Alright, so the first thing we're going to need to do in order to start looking at the structure data is to get a tool to actually view it. And the tool that I use is NBT Explorer. This is a tool for Windows. You can download it from the Minecraft forum. I'll put a link in the description and you can go there, download it, thank the guy who made it. It's a great tool, really easy to use, really easy way to look at Minecraft data. It doesn't just look at structure data, it looks at any Minecraft data, entities, items, chunk data, pretty much anything. It uses the NBT format, which is named binary tag format, and that's what Mojang uses for all of their data, internal and external. So pretty cool and easy to work with. So go ahead and download it. You just have to extract it to a folder and then run it, and it will bring up your save files. So this is my default save folder, just all the worlds that I've created. As you can see, I've only got one here. I called it Fun with Structures. We can go ahead and open this, and you can see all the data inside. Now, what we want to look at is structures, so don't worry about anything in here other than this folder that says data. Go ahead and open it up, and what you'll see is a bunch of .dat files. We've got fortresses.dat, mineshaft.dat, temple.dat, village.dat, and villages.dat. These are all data that gets saved to the hard drive by the game. There would also be stronghold.dat in here. If I had actually loaded some strongholds, that would get saved, but I haven't, so we don't have that yet. But these are all the files, different types of structures that can get saved. And, well, except for the villages here, villages is actually not structure data. It's more of a virtual representation of door positions and door ages and center of the village and stuff like that. So not really what we need for the structure data, but it's also a data file. So don't pay attention to this for this tutorial, just pay attention to all the others. These are the data that we want to work with, and these are the ones that we're going to explore. So let's go ahead and open up fortress.dat, and I'll start explaining how all of this is set up. Okay, so when we open the fortress.dat file, what you'll first probably notice is you've got tags, and inside of those you've got more tags, and inside of those tags you've got even more tags, and those tags have their own tags, and those tags have even more tags, and you've got this huge sprawling structure that sort of fans out like a giant tree. That's actually appropriate because this type of data view is called a tree view, and it's both describing the way the data is set up on the hard drive, but it's also describing how the data is interpreted by Minecraft. And this is important because it tells us that if we look at this fortress.dat file, this is containing all of the information for the structure generation for nether fortresses. So all of that's saved here under this data tag, and if we look at that, we'll see, okay, the structure generator has two tags underneath it. Those are the structures that actually did generate. So in our case, we have two. That means we've actually generated two nether fortresses. Then if we go ahead and open up one of those, you can see, okay, each nether fortress has some information about it. Inside of it, there's another set of tags, another branch where it goes off into a bunch of directions, and oh, all these little pieces, these are all the little components that build up the main body of the structure. And of course, I'll go into all the details of how all this works later, but the idea is pretty important to understand not only how it's saved on the hard drive, but to understand how Minecraft interprets it and make sense of it and actually play around with it and do cool stuff with it. So, like I said, we'll get into all the little details later, but let's start from the top and go step by step on all the information about what you need to know and build out these files and understand them. Okay, so to talk about this, we should, like I said, start at the top. And for us, the top of our data really begins at this features tag. This features tag tells us which structures have generated and how many. So for fortresses, it tells us that we have had 2 structures generated, and inside of here the names tell us which ones they actually were. Likewise, if we look at mineshaft.dat and go to the features there, we can see we have 6 mineshafts that have generated and which mineshafts actually did generate. And all of this is, like I said, part of a system that is sort of hierarchical. We've got the main structure generation here, and then inside of that we can see we've got each independent structure that has generated. Now if we go ahead and open up one of these structures, so let's open up this one, we can see we've got some information about it. First things you'll see, we've got chunk X and chunk Z. This is the actual location of the structure, and that's the same as the name there. This is important for a couple of reasons. First of all, it of course tells us where it is in the world, so we know which structure we're looking at. But it also tells the game, okay, there's already a structure at chunk 10 minus 9. That means if the game were to load that chunk again, it would want to load this structure and not try to generate a new one, because there's no need to generate a new one as this one already exists. Next, we've got an ID tag here. This ID tells the game what type of structure it is. It's what type of object it needs to create when it's rebuilding or reloading these structures into the world. And in the case of fortress, this is of course going to be fortress. In the case of mineshaft, it will be mineshaft. Temple, it will be temple, of course, and village, village, stronghold, stronghold. And it's like that for all of them. So an ID that just tells us which thing we actually want to generate. Next, we have this children list, and this is actually a big list of entries. I'll just briefly open it here. We'll get into the details of that in a moment. But it's just a long list of all the little components that build up a structure. Because, as you know, a nether fortress isn't just one piece. It's a bunch of little pieces that fit together to make the unique designs. Then we've got this BB tag. This BB tag is the bounding box. And this is identified by 2 coordinates, the smallest x, y, and z coordinate and the biggest x, y, and z coordinate. Using those 2, we can define the size of a box that contains all of the structure information. Alright, so that's going to be the same pretty much for any of these features. Any of these features are going to all have that same information. Now, where it starts to get interesting and start things to have things that change is inside of the children here. And that's what we're going to talk about next. Alright, so let's go ahead and open up the children list here. And inside, you'll see the number of entries as the number of small components that actually build up the main structure. So for this particular fortress structure, this main sprawling nether fortress structure, we've got 92 entries. This won't be the same for all of them because they're randomly generated. So this one, for example, has 157. That's quite a few more. Then even for mineshafts, we've got ones with 200. But some things, like temples, for example, only have 1. Or villages, which have many fewer entries, only have 21. So it depends on the actual size of the thing, how many pieces it generated, how large the structure is, and how random it is. So lots of stuff here, but this is just the list of all the little individual components that make up the structure. Now, inside of each of these, there's some tags. And a couple of these you probably already recognize. You've got ID here and BB. Those are, of course, the ID, which tells us which structure. So this would be an NE start piece. This would be an NERC piece. And this would be an NESR piece. And whatever that means, it's just a way of Mojang identifying them in the code so that when they're reloaded, it knows which piece to put together to rebuild this virtual structure and get it just right. Now, the bounding box, of course, is this BB, and this tells us the actual size. And while this is determined when the structure actually gets placed, you can change it around if you know what you're doing, and we'll get into that, of course, later. Then there's some more tags. In every one of these pieces you see we've got a GD and an O. These are just stuff that come with the generation. The GD is the recursive step counter, so it tells us how many times it's had to step away from the start in order to generate a piece. And the O is the direction. So these aren't really used for anything that we need, but maybe in the future Mojang might add something like structures that will randomly grow, or maybe villagers will be able to build onto structures and make villages bigger or something, and they might need to know what the recursive step is or the direction so that it grows in the right way. So could be something interesting in the future. No idea, but that's an idea. Who knows? The ones that we really care about are this bounding box and maybe the ID. We don't really care about the ID for nether fortresses because it doesn't tell us too much. It doesn't really have an effect. It's the same all over. For some things like temples, which I'll get into later, it may be important. Now, in addition to these 4, sometimes you have others. So if we go down here, you'll see we have 5. If you look at this, you see there's another tag mob, and then let's open up another one. This one also has mob, but the value here is 0 and the value here is 1. Well, the reason for this is this NEMT piece, whatever this means, is actually the piece that generates the blaze spawners. And this mob just tells us, did it generate a blaze spawner? So 1 would be yes, it did generate one, and 0 would be no, it didn't. Now, of course, if we were to change this to 1 and load up the world, there wouldn't be a blaze spawner there because that's already generated. It's just loading the virtual structure and telling it, okay, this is a piece that should have generated a blaze spawner. Now, this doesn't play a role yet, but maybe in the future Mojang might do something like say, oh, if it's a piece that did generate a blaze spawner, maybe blaze spawning is actually more frequent there. Who knows? Anyway, this can vary quite a bit. In nether fortresses, there's not much variation, but for some other things like mine shafts, for example, let me go ahead and open up one. If we go to the children here, you can see we've got 4 entries like we would expect, but then we also have some with 8, a bunch of different things here, and then there's some with 5 like this, which is our MS room, whatever that means, and then mineshaft room, I guess. And then here's one with 6, mineshaft crossing. So a bunch of different ways things can be arranged, and it's just information that tells us how exactly to rebuild everything when the game loads it, so it can be exactly as it was when it's saved. And that's the key here. Because it's saved so precisely, we have so much control over what we can do by editing this data. Now, let's talk about what we can do to actually change some stuff. And to do that, let me close all of these because this is a bit confusing to have all of these in your face. Let's close all of the fortress stuff and go down to temple. So, as I said before, temples are pretty simple. They've only got 1 in the children. And this is what we're going to look at. So let's go ahead and open the temple file up here. And then I'm actually going to open up Minecraft. And what we're going to see is a temple. In this case, it's a witch hut that we're going to modify. So bring up the Minecraft session here. Give me a moment. And I'm already at the location. I've already gone to 10:13 where our witch hut is. I was standing in front of it. If you look, you can see I am in fact at chunk X position 10 in the chunk X 10 and chunk Z 13, just like it says here. So this is the witch hut that we are wanting to modify. This is the one that we do want to change. And the first thing we're going to do with it, of course, is play around with the bounding box because, hey, haven't you always wanted to see a witch hut with a bounding box that's not the same? Now, to actually get an idea of what we're doing, I've installed a mod, and this mod, if I turn it on, shows me the bounding box of the witch hut. So as we can see here, we've got a witch hut with a normal bounding box, 7 by 9 by 5, exactly where we expect it to be, normal, vanilla, boring witch hut. Now we want to change it, and that's what I'm going to do. So let's take a look at this bounding box tag. So this is our next step. Okay, now to talk about this bounding box tag, I've gone ahead and closed the Minecraft session just because it's going to be in the way. This next part is pretty technical, so don't want anything to be distracting. So go ahead and double click this to bring it up. When you do, what you'll see is this window, Editing BB, and this has all the information that's stored in that bounding box tag. Now the format, if you're not a computer scientist or a programmer or don't know anything about hexadecimal, is sort of close to how a computer might interpret it. It's hexadecimal represented as bytes, where each of these 2 characters represents 1 byte. So hexadecimal is just a different way of looking at numbers, whereas decimal would be what you would normally see, just 0 through 9. Hexadecimal is 0 through 9 with A, B, C, D, E, F. So just a way of looking at numbers differently, and don't worry too much about it. There are plenty of hexadecimal to decimal converters out there. Just do a search on the internet, you'll find them. Or if you're using a machine that has a calculator that has a programmer mode, it probably has a mode that you can type it into hex and then just convert to decimal, or type it into decimal and convert to hex. So don't worry too much about the hexadecimal point, just worry about the actual information that's in here. Now, the tag here says there should be 6 integers, but just looking at it, you see it looks like a lot more values. But as I said, this is sort of closer to how a machine might read it, how a computer might interpret it. It's byte by byte. Now, each integer in here is represented by 4 bytes. And if you remember, I said each byte is 2 of these characters, so our first integer would be these first 4 bytes. So just like this. So this would be our first integer. And that is, in fact, the case. We could also see this is our second, this is our third, fourth, fifth, and sixth. So there we go, 6 integers. Now, what these represent are the minimum x, y, and z position and the maximum x, y, and z position. So our smallest corner and our biggest corner. And that can tell us the actual size of the bounding box and its position. So all of that information just stored in these 6 integers. Now, how do we actually read these and figure out what they mean in decimal? Where are these coordinates in the actual game? Well, the way to read it is to read it byte-wise, going from the last byte to the first byte. So for a particular integer, you have 4 bytes. The last byte is going to be the fourth one, and the first one is going to be, of course, the first one. So you would go reading 00, 00, 00, 00, A0. And since each of these is a byte itself, you would want to read each of these left to right. So it would be 00, 00, 00, 00, A0, and if we go ahead and type that into our hex converter, 00, 00, 00, 00, A0, here you can see it cut off the leading zeros, but don't worry about that, it's still fine. Convert it to decimal, and you can see we get a value in decimal 160. Now, does this match up with what we expect? Well, the chunk x is 10, and if we multiply 10 by 16, because each chunk is 16 blocks, yeah, that makes sense. Being around chunk 10, we should have a x position around 160. So that makes sense to me. What about our maximum x? If we look at this, we see A8 here, or it would be 0, 0, 0, 0, 0, 0, A8. And if we convert that to decimal, 168. Okay, that makes sense too. And really easy way to actually understand the values that are stored here. So you can look at any of them here: minimum x, minimum y, minimum z, maximum x, maximum y, maximum z. Any of those values, just use that method and you can interpret them easily. Now, it's a little bit different for negative numbers, but I'll show you how to interpret negative numbers at the very end, because it's a little more complicated, but the idea is still pretty much the same. So that's how you understand the bounding box coordinates. Now let's pause for a bit and then load up the Minecraft session, and we can actually do some modifications with them. Okay, I've closed the bounding box window, and now I'm going to bring up the Minecraft session again, Minecraft session. And once we get into the world, I will bring up the bounding box mod again and the debug screen, and we'll take a look first at the coordinates. So our x coordinate, we have this value here at 160, and if we go up in the x, we have another value here at 168. So exactly what we had calculated and interpreted from the hexadecimal values, so that's good to know. Our minimum and maximum x matched our expectation. We know how to look at that data and how to analyze it. Now we have to actually look at changing it, and to do that, well, I want to grow it and make this bounding box bigger, because as I said before, this is really a pathetic bounding box. Nobody really wants a tiny witch hut, right? So if you're a map maker, or if you don't mind playing outside the realm of vanilla, you can do whatever you want to the bounding boxes of your witch huts. In our case, we might want to make it bigger. and we're going to make it bigger in this direction, which is the positive z direction, and in this direction, which is the negative x direction. Now, knowing the direction is important because it determines which value we need to change and how we need to change it. And I'll get into that in a moment. Just let me save out of here, quit game, and go back to NBT Explorer. All right, now that we're at NBT Explorer, since we just were in the game and we're going around, we may have created some more data. So I'm going to go up to the top here to our data folder and click refresh content from disk. Just do this to be safe, because if you make some changes, it might interpret it a way that you don't want and corrupt your world or not let you save it. So just go ahead and be safe and reload everything to make sure you've got the latest, greatest, and most up-to-date version. Once you do that, go back and navigate to wherever you're going to make your change. In our case, it's the child tag here inside of our temple and the bounding box, of course. So go ahead and open that up. And like before, exactly as we left it, we have our minimum value A0, which is 160, and our maximum value A8 here, which is 168, and all the other values, of course. So, how to make the changes? Well, if we're making something bigger by extending it out towards the minus direction, so like we're going to do with the x, we want to make it bigger towards the minus x direction. We want to make the minimum value smaller. The reason for this is because we want to increase the distance between the maximum value and the minimum value, but since we're going towards the minimum direction, we don't want to change the maximum value at all. So we'll make the minimum value, that would be this value in the x, or one of these three values for the x, y, and z. In our case, we want to change the x, so we'll make our minimum x smaller, and that will extend it out. Now, let's see, it was 160, right? Oops, clear that. 160, and we want it to be 10 blocks longer in the x. So since we're going smaller, we need to subtract that. So just subtract 10, and of course that's going to be 150. If we convert that to hex, we get 96. So let's just put 96 here. So that's our x value. Now for the maximum, or the z direction, we want to make the maximum bigger because we are going to the positive z direction. The reason we want to make the maximum bigger, of course, is like before, we're increasing the distance between the maximum and the minimum points. And since we're going in the positive z direction, we don't want to change the minimum value, we want to change the maximum value. So make the maximum bigger. Our maximum z here is d6. If we put that in hex, convert to decimal, we get 214. Okay, let's make it bigger by 10. That is, of course, 220. Convert that back to hex, we get E0. So let's make that E0. Okay, we're done making the changes there. We could go ahead and save this and load it up in the world and we'd see the bounding box change, but we need to make one more change to make sure it's actually going to be interpreted by the game and working in the game, and that's to make the overall bounding box and close it. So you've got these children, which are inside of your main structure here, and they all have to be within that bounding box for the main structure. So the main structure has its own bounding box, and each child has its own bounding box, and all of the bounding boxes for the children must be within the area of the main bounding box. Now, for the case of a witch hut, these are going to be pretty much the exact values because there's only one structure and it's just one bounding box. So we can just open it up and you see it had the exact same values as our component piece. We'll just change those to what they are now. So this is 9.6 for the minimum x and E0 for the maximum z. So go ahead and make those changes, save it. Now our main structure completely encases the interior structures. You can also have the main structure be bigger. As long as it has everything inside, it will be okay. All right, now let's go ahead and load it up. Bring up the Minecraft session again. And when we hop into the world and look at the bounding box, you can see it is indeed bigger in the direction that we wanted. Our negative x that way and positive z that way. Now let's go ahead and do some measurements here. I'm just going to count some blocks out to make sure it's the right number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we did in fact make it 10 blocks longer in the X. Alright, for, whoa, lag there. For the Z, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also 10 blocks longer in the Z. So 10 blocks longer in the X, 10 blocks longer in the Z. Exactly what we wanted. But, this still isn't really very cool, right? It's bigger, but this isn't really what we want. We want to make something even more exciting. And to that, we'll just make it even bigger. And the size I want it is bigger than this. Let's go all the way to the water edge here. So we'll go all the way over here to 130. So we'll make our Z 130 and our X, let's bring our X all the way down to this edge, which is 100. So we'll make our X at 100 and our Z at, did I say 130? 330. So 330 for our Z, 100 for our X, so it should be from that very corner to this very corner. Big, sprawling witch hut. Yeah, we'll make the entire area here a witch hut. Alright, so I'm going to go ahead and close this out, switch back over to NBT Explorer, and we'll go ahead and make that change. Okay, got the Minecraft session closed once again, and let's bring up the bounding box window again. So now we want to change our X to be 100. So let's just go ahead and type 100 in decimal, convert to hex. That's going to be 64. So 64 for our minimum X. Then our Z, which is going to extend out to 330. Let's type that in decimal, switch to hex. 14A. Now remember, there would be leading zeros here, so we'd have to keep those in mind. So it would be 000001 for A. So we want to type that in as it would be. So 000001 for A for our maximum Z. Okay, so that's our X and Z changed. Now we've got it all the way across the region that we wanted, but as you may have noticed when we were flying over, we won't really get witches spawning because the ground level isn't quite high enough. So let's drop the ground level down a bit. That means we need to change our minimum Y, which is at 40 right now. So minimum Y at 40, that's 64. Okay, yeah, 64 of course makes sense. Let's drop it down to 60. So we would just make that 60, switch to hex. That's 3C. So 3C for our minimum Y. So now we've expanded out our witch hut even more, made it a little bit taller by dropping down the bottom by a few blocks, and now it should cover that entire area, and that entire area should be just covered with witches when we go back in. So let's go ahead and change our outer bound, our main structure bounding box as well to match that. That was 64, and it was 01 for A, and for our minimum Y, what was it? 3C, right? Okay, those have been changed. And then we need anything else? Nope, that was all. So let's go ahead and save it, and we can load the map again. Give it a moment. A long moment. Okay, here we go. We go back in and of course bring up the bounding box, and you can see it's big. It goes all the way out here. You can see it goes down some blocks too, and well, it's daytime, so we're not of course getting any witches, but let's switch it to night. And as soon as we do, well, I guess all the mobs are underground. Toggle difficulty here. Witches spawning in the middle. Ooh, lots of witches. Okay, so yeah, as you can see, this entire area now spawns witches because we've made it into a witch hut. One huge, giant witch hut that covers the land. Isn't that great? That's pretty cool. But it's not very fancy. There are even cooler things we can do. So let's once again get out of this and do something even neater. Before we leave, let's go ahead and locate some blocks. this is an interesting area here. Let's go ahead and put down some markers and record these coordinates. So this is a z 240 and x 182, and then let's go out over here to z 264 and x 215. Alright, so we'll remember those coordinates and we'll do something fancy after we go back to NBT Edit. So let me close out this screen and switch back over to NBT Edit. Alright, so closed out that Minecraft session, refreshed the data in NBT Explorer, and gone back to our witch hut. So we have it open again here, and now we're ready to do the thing that I said is even more fancy than just making a giant witch hut. And that's going to be to actually make our own. So yes, we have enough power to make our own witch huts. And to make it even more fancy than that, I'm going to make a witch hut inside of a witch hut. So normally these temple structures only have one entry inside of their children list. I'm going to go ahead and add another one and make a witch hut inside of here. So a second witch hut inside of this temple. So we'll have two witch huts inside of this witch hut. So to do that, I'm going to start by just taking this entry here. Go ahead and click copy up here, and we can just take that copy and paste it in. So now we have two children in the list. Now they're exactly the same right now, which isn't what we want. We need to change one of them to be at the new coordinates. Those are the ones that I marked out. So go ahead and bring up the bounding box, and we're going to just change the coordinates to match the ones that we marked out. We'll leave the y coordinates the same because really that doesn't matter too much. We just want the height to be enough so that they're within spawning areas. So okay, that means we're changing our minimum x, our maximum x, our minimum z, and our maximum z. So to start, our minimum x is 182. So let's go ahead and do that. 182, convert to hex, that's going to be B6. So B6. Then our maximum x is 215. So 215, this should be D7. Yeah, D7. So go ahead and change that to D7. And then our minimum z should be 240. So go ahead and do that. F0. And then our maximum z should be 264. So let's do 264 here. Convert to hex. 0108. So we have 01 already. 08. Okay, so that should be it. That should be the bounding box of our new structure. Now, or our new structure component, our new structure piece. So now we have a witch hut piece inside of our temple main structure. Doesn't spawn yet because we need to make the bounding box of our main structure fit it. And to do that, let's open that up. Now, all of these I think are containing it except for the maximum x. So we just need to make our maximum x larger to meet the maximum x of the structure, which was 215. So if I remember correctly, that was D7. So now it should contain everything, including our new structure. And if we go ahead and save it, then go to the world, go ahead and launch the world up, and bring up the bounding box, of course. As you can see, we now have another bounding box out here, and it is spawning witches. So let me go ahead and toggle peaceful again, just so you can see them actually spawn. Difficulty 0, then change it back to hard. Okay, all the mobs spawned around it. Let's try that again. Difficulty 0, difficulty hard. Come on, guys. There you go. Lots of witches spawning inside of our witch hut. So now we have a witch hut with a witch hut and then another witch hut. So put a witch hut in our witch hut. So yeah, now we have two witch huts inside of a single temple structure. That's pretty cool. What else can we do? Well, let's switch back to NBT Explorer and play around with it a little bit more. Alright, so the next thing I'm going to do is, instead of just creating a structure piece inside of a structure, I'm just going to try to create an entirely new structure. So as if it were generated from the world, an entirely new structure. And to do that, well, I'll just use one of these features, go ahead and copy it, paste it. You can see it just comes out for now as 1013 copy, so we need to change that name. Go ahead and edit the name. I'm going to change it to be something close to what I want it to be. It doesn't really matter what it is as long as it's pretty close. So it doesn't even have to be pretty close, but I want it to be pretty close because it's easier for me to recognize that way. So we're just going to change it to 1613. That's about where I'm going to build the structure. Go ahead and change the chunk X, change that value to 16 to match the name. Then we can go into children. We only need one of these, so just delete one of those. Then change the bounding box. So I've already written some values down, and we're going to have our minimum X at 250, which is going to be FA, our maximum X at 310, which is going to be 0136. So 0136. Then our minimum Z will be at 220. That will be DC. And our maximum Z will be 280, which is going to be 0118. So 0118. Alright. I'm just going to leave the Y as it was because it's a good height. I like it at that height. Alright, so we got that. I'm going to go ahead and make those values the same for the overall structure bounding box as well, just to make sure those work out. So it was FA for the minimum X, then 0136 for the maximum X, DC for the minimum Z, and it was what was it? 0118. Okay, there we go. So go ahead and enter that in, save it, and now when we go into the world, what we should see is another bounding box around these coordinates. That should be a witch hut. So let's go ahead and go there and see what happens. Load up the world once again. Fun with structures. And let's turn on the bounding box. And difficulty peaceful. Fly over there. Difficulty hard. Can we see witches spawning? I don't see any yet. Oh, there they are. Yep. So it's working. We've got them spawning in here. Let's go ahead and do it again just to show them actually appearing, because I didn't see them appear this time. Oh, there we go. Yep, they're appearing inside. So yeah, as you can see, I've created a completely new structure, one that wouldn't have been generated by the map generation at all, and inside of it a witch hut. So that's another thing that you can do. And the next thing I'm going to try is to actually switch the type. So let's try to change this from a witch hut to something like a desert temple and see what happens there. So let me go ahead and close out this session and we'll get to switching that. Okay, so the one that I'm going to change, the structure that I'm going to change, is this new one that we just added as if the world had generated, even though the world didn't generate it. And I'm just going to change it so that it's something different. You might be wondering why you may need to do this. Well, there isn't really any reason to change them typically. It's non-vanilla anyway. If you wanted to have something, you could create it. But let's say, for example, you had in 1.6.2 a desert pyramid that bordered on a swamp. And in 1.6.2, these could spawn witches. But in 1.6.3, they fixed that. So now only desert or witch huts actually did spawn witches. So if you wanted to keep that functionality, say you invested a lot of time into it, you can actually go in there, change the desert pyramid ID to a witch hut ID, and then whenever, and all the other things, make sure they're right so it loads properly. And when you do, it will load witches will load, and everything will work just fine. So we're going to sort of do the opposite here. We have a working witch hut, and let's break it, make it a non-working witch hut. So we're going to switch it to something that is also going to be, should be ID temple. You can actually use something that's not ID temple, but I don't think that's necessary. So just go to, we've got another thing here. This is a jungle pyramid. We're going to go ahead and take the information from here, pretty much copy it in. So the ID will just take that, change it from TESH, which stands for Temple Swamp Hut, change it to TEJP, which stands for Temple Jungle Pyramid. This witch value we don't need anymore, so go ahead and delete that. Then take all of these different values in here and copy them in, just to make sure the game loads it properly. They may not be necessary, but they may also be necessary, just to make sure we'll have them all in here. Now, these other ones, width, H position, height, depth, and also GD and O, these don't have to be changed to match. They don't even have to change, as you saw, to match the bounding box. These are just created when the thing is generated, so don't have to worry about those too much. Just make sure you have something with the same name and the same type. So you can see all of these are the B type, which is byte, and all of these are I type, which is binary. And just make sure it all matches up, just to be safe. Right? Once you've done that, go ahead and save it. And now we should have created, or switched rather, our witch hut to a jungle pyramid. So now if we go ahead and load up the game, bring up our map, fun with structures, and see we've got some witches left over here, and if we difficulty peaceful, switch to hard again, no longer witches spawning. Now instead we've got normal mobs, slimes, zombies, whatever kind of mess you might have in a structure that isn't a witch hut. So as you can see, we broke it by switching it to something that isn't a witch hut. You could do, like I said, the other way around. If you had a desert temple that was overlapping a swamp and it broke between 1.6.2 and 1.6.3, using this method and doing the reverse, you can fix it. So that's pretty cool. And I think that's pretty much all that I have to show you. With all of these methods in hand, you can pretty much do anything you want. You can change structures, you can add to structures, you can make new structures, you can duplicate structures, you can do pretty much anything as long as you get a handle on how to manipulate the data here, make sure it lines up correctly, make sure you're saving it properly and all that. So that's pretty much all, but there is one more thing. That's how to handle subtraction, or sorry, not subtraction, negative values in the bounding box. So let me go ahead and give you an example of why that's a little different. If we go to this jungle temple, you'll see we do have a negative value in the X here, and that is going to show up in our bounding box here as well. You can see our X positions have these FFs in front. And let me go ahead and load up the world and hop over to that position. It should be around chunk minus 15. So let's go just teleport over there to show you. So TP to, so it's going to be around 240 and, oh no, not 240. Yeah, 240 and 320. So, oh, yeah, there it is. And if we look at the bounding box and also have the debug screen on, you can see our X position is at minus 239 and minus 228. So how do we interpret this and how do we make sense of it? Well, you can also just look at it in hex like I did before. Let me go ahead and exit out of this so it's out of the way. Bring up the bounding box again. But there's a little bit of extra calculation that you have to do. So I'm going to bring up another calculator. This one I'll have in scientific mode. And what we have to do here is pretty simple. We'll read in the values the same way. So our minimum X is going to be FF, 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 10. If we convert that to decimal, we get this value. Not what we would expect, not a negative value, but we can do a simple calculation to fix that. Just copy that value into your other calculator, subtract from it 2 to the power of 32, and then add 1. And the result, there's your minimum x, minus 239, just what we wanted. And if we wanted to look at the maximum x here, you can see that would be FF1b. Convert that to decimal, you get this big number. Go ahead and copy that into your other calculator, subtract from it 2 to the power of 32, and then add 1. And there's your value, minus 228, exactly what we expected. So negative values, not too hard, just make sure you recognize them. They're going to have this sort of F setup. This first number will be an F, and that's really your key to know that it's a negative value. So that's all. That's how you interpret pretty much all of the structured data. That's how you know how to do everything. So go out, have fun, make structures that are crazy and interesting, and hope you enjoyed this video. So thanks for watching, and I'll see you next time. Bye.